Hello, everyone. We are here. We are in chapter 6. And the big idea that we're going to be exploring here is exponential functions. But we're also going to look at some other properties of exponents and some ways to express exponents and powers. So here we go. Properties of exponents is lesson 6.1. I'm hoping some of this content is familiar for you, but if it's not, that's okay. We'll work through it. What I want you to do in your warm-up is evaluate this. So again, if we kind of unpack this a little bit, 2 is the base. It represents the number that we are multiplying. 5 is called the exponent. It tells us how many times to multiply the base by itself. And when we look at this, the whole thing is a power, and this one particularly is said 2 to the 5th power. Some powers have other words, like if you have something to the 2nd power, you can use the word squared as a shorthand. Something to the 3rd power can be cubed. And so when we evaluate a power, we look at the number of times the exponent tells us to multiply the base. And again, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Powers, again, are quick shorthand ways to write repeated multiplication, just like multiplication is a quick shorthand way to write repeated addition. So there's like a bit of a theme there. And you might also have seen powers in our order of operations, which we sometimes abbreviate as PEMDAS, because exponents are the second thing that are evaluated in the list of order of operation questions. I tried to put some of these ideas embedded into some of your warm-ups leading up to this unit, just so we could have some additional exposure. So we have 6 properties that we're going to be looking at. And one of the things about these properties is that all of the rules combine with other rules. And usually there's not necessarily an order that you have to do them in, as long as you combine them properly. So we're going to start with the first rule, which is the product of powers. Product meaning multiplying. So we are going to be multiplying powers, and for this property to work, the powers must have the same base. So if you notice, I have an algebraic way of writing this. So something x to the 8th power times x to the bth power. So a and b are our exponents, x is the base. If we have this situation, then we add exponents. And so if I have x to the a times x to the b, my result is x to the a plus b. I'm going to use this example here, 4 to the 5th times 4/3, just to draw that out a little bit more for you and make sure you know why it's happening, especially if you haven't seen this before. So again, if I were to do 4 to the 5th power and write it out as I did in my warm-up, and then I were to write out 4 to the 3rd power, I would notice that I have 1, 2, 3, 4, 5, 6, 7, 8 4s all being multiplied. So I could collapse that back down to 4 to the 8th power. And again, looking at that pattern and making it into a more generalized idea, what I did was add the exponents. The second example, my base is -2. And this is one of the things I'll definitely be emphasizing throughout the chapter, but when your base is negative, it must go in parentheses because it means something different when it's not. And I'm going to show you that once we have our calculators and get to some evaluating. So anyways, I have -2 to the 2nd times -2 to the 9th. So I have -2 to the 11th power because 2 plus 9 is 11. And then my last example, b cubed times b. So this example I wanted to bring to your attention because I don't see an exponent. And anytime I don't see an exponent, it's actually a 1. It's not a 0. B to the 1st power is itself. It's b. So b cubed times b is b to the 4th. Okay, so that was our first example, product of powers, our first rule. Our second rule is the quotient of powers, quotient meaning to divide. So we are dividing two powers, again, with the same base. If we have a different base, we cannot use this property, cannot use this rule. There are ways that if you have something with different bases, if you can get to the same base, then you can apply the rule. That's actually a little bit beyond us. Might be like a bonus question or some challenge question, but not something we're going to see regularly. This time we are going to subtract. And when we subtract, the order of a subtraction problem is really important. We always do numerator exponent minus denominator. That might result in something negative, which I will address later on. So if I have x to the a divided by x to the b, that is x to the a minus b. Again, a is my numerator exponent, b is my denominator. Let's look at this example by writing it out again. So 10 to the 6th power is 6 tens being multiplied, and 10 to the 4th power is 4 tens. Now, when I divide, what I can actually thinking about doing is I can divide or cross out common factors. So if I, for example, have a 10 in the numerator and a 10 in the denominator, I can divide those numbers out, divide them by each other, and I get a 1. I can do that again with the second set of tens, one and two more times, third set of tens and fourth set of tens. And what that leaves me with is 10 times 10 in the numerator. And actually what I have down here in the denominator is a 1. And what I will be then have is 10 to the 2nd power. Again, the squared was in the numerator, so this is 10 to the 2nd power. And 6 minus 4 is 2. For this one here, h to the 12th divided by h to the 5th is h to the 7th. So again, you might be asking yourself, what happens if I have h to the 5th over h to the 12th? That's a different question here because I'm going to end up with a negative, and we will talk about negative exponents as well. So we can use that quotient rule that we just discussed in combination with another rule. And then the last question that I'm going to talk about in this first video, I'm going to break this into 2 videos, is power to a power. So I'm going to start with a power, as you can see here, x to the a, and then I have parentheses around it because now I'm going to have a power as a base, and I'm going to raise it to another power. In this case, our rule is to multiply the 2 exponents together. So x to the a raised to the bth power is x to the ab. Let's look at this again, break this up. 6 to the 3rd to the 5th. Again, this is 6 to the 3rd, and I'm going to take 5 copies of 6 to the 3rd and multiply them by themselves. But then what I actually have is a product of powers. I have a bunch of 6 to the 3rds being multiplied. They all have the same base. And if I added my exponents, 3 plus 3 plus 3 plus 3 plus 3 is 15. But the quicker way to do that, of course, would just be to multiply 3 and 5, which are my 2 exponents. For this next one, q to the 7th to the 3rd becomes q to the 21st. So this is our first set of 3 power rules, and the second video is going to give us the second of the second group of 3 power rules.